Hello students, in this video we are going to discuss 5.3 from work, energy and power. Given in figure 5.11 are examples of some potential energy functions in one dimension. The total energy of the particle is indicated by a cross on the ordinate axis. In each case, specify the regions, if any, in which the particle cannot be found for the given energy. Also, indicate the minimum total energy of the particle must have in each case. Think of simple physical contexts for which these potential energy shapes are relevant. Coming to the first one, assume that it is diagram A. Potential energy is taken along y-axis and x is taken along x-axis. Here from 0 to A, potential energy is given as 0 and here potential energy is given as V0. So generally we have the total energy I am indicating E is equal to kinetic energy plus potential energy, where E indicates total energy, K corresponding to kinetic, V corresponding to potential energy. From this, kinetic energy is equal to E minus V. That means kinetic energy is always positive or 0, can't be negative. Therefore, E should be more than or equal to V. The magnitude of E should be more than or equal to V. This is the condition. Here, in this region, when X is for X is more than A, kinetic energy value is negative, K is negative, but the particle cannot exist in the region where X is greater than A. That means in this region the particle won't exist. Coming to one more, minimum total energy. Here, the minimum total energy can be is equal to 0. Coming to one more part, B. For this one, everywhere the V0 value, potential energy value is more than E. So kinetic energy is negative. So kinetic energy can't be negative, anywhere particle won't exist. So in every region of the graph, potential energy is more than E. That means kinetic energy is negative. That means the particle cannot exist in all these regions. So what is the value of E minimum? Here, to get E minimum, here E minimum value will be V naught. So this is nothing but V naught. Coming to, suppose say it is question number C. Here, in the region below A and above B, for x is less than A and x is more than B, potential energy value is more than total energy. That means kinetic energy is negative. That means the particle won't exist. So within these regions, the particle can exist within this region. So here E minimum value is equal to this one, minus V1. Coming to, suppose if we are naming it D. In this region also, for minus B by 2 is less than x is less than minus A by 2. That means in this region and A by 2 is less than x is less than B by 2. That means in this region potential energy value is more than total energy. That means in this case kinetic energy is negative, which is impossible in these regions. So in this case, what is the value of E minimum? The E minimum is nothing but minus V1 here. So this is the solution of this question 5.3 from work, energy and power. Thank you.